Welcome back, everyone. So on example 15 again, if you would like to try example 15 on your own, I encourage you to do so. Like if it's making sense and you're like, Miss Long, like I know you're like trying to help me, but I already get it. Okay, if that applies to you, I encourage you to try this one on your own, and then you can fast forward to the end of the video and see if you get it right. Otherwise, let's follow along with Miss Long. Let's go. Okay, so again, the first thing we're trying to show is how are the triangles similar? Which in this one we're looking at these two triangles. We're looking at the little triangle right here, and we're looking at the larger triangle right here. Okay, so again, if it helps you to like separate the two triangles, I encourage you to do that. Like it might be better for you to do this triangle and then separately draw triangle HRE. Okay, so I'm just going to do it all together because I think probably a lot of you can visualize it. Now that we've done a few of these, you can probably visualize, what the side links are. And I just realized I didn't put my side links on, so after I show you how the triangles are similar, I will add in these side links. So we will need to add in some side links into our picture, but it'll be okay. Okay, all right, so first of all, let's figure out how these two triangles are similar. Okay, which we've done one that's kind of similar to this before. Okay, so first of all, do you guys see a shared side in a shared angle in my two triangles? So we have triangle HOS and triangle HER. Which angle or which letter did I just say two times? Which angle is in both of my triangles? Insane, you guys. It would be angle H. Guys, so I'm going to mark angle H in my picture. Guys, so angle H is not only in the little triangle, it's also in my big triangle. So I know that they share the same angle, which means they have a common angle, and that means that angle H is congruent to angle H. And what is it called when we have a shared angle or when we have something is congruent to itself? It would be the reflexive property. So this is the reflexive property. All right, now the second way we can mark angles in our picture, okay, do you guys see these little sneaky arrows right here? What do those arrows mean? They mean parallel lines. So whenever you spot any parallel lines, that means any of those nifty angle pairs could appear. So we're looking for like corresponding angles, alternate interior angles, alternate exterior angles, or same side interior angles. Okay, so we're looking for one of those shapes to pop out at us in our picture. Okay, so do you guys see like an F or Z or a C or like the two V's? I see it too, guys. Do you guys see the F? So there's actually two F's. There's one right here, okay, and there's also a backwards F right here. Do you guys see both of the F's? Okay, and then do you know what the F angles are called? They are called corresponding angles, and how do corresponding angles relate to each other? They are congruent. So I know that angle R is congruent, I'm going to put two arcs, to angle SOH. And I know that angle E is congruent to angle OSH. And how I know is because the corresponding angle postulate. That tells me that corresponding angles are congruent. Okay, so you can mark just these two or just these two. I'm going to include both because we might as well list them, right? So I know that angle R is congruent to angle HOS. Okay, or we can say angle E is congruent to angle OSH. And how I know is because the corresponding angle postulate. Corresponding angle postulate. Okay, so remember, all we need in this case, since I have three angles marked congruent, that is enough information to show that triangles are similar. And technically, I only needed two angles to be congruent. Okay, so now I know that my triangles are similar by a similarity. Okay, and now that we know triangles are similar, now I know my side lengths are proportional, which means I can solve for x and y. But, you know, the Demon Cat's got Miss Long, and I need to add in my side link. So let me do that really quickly. Sorry, guys. I normally am more prepared than this. So in this one, let's see here, in 15, let's label our side link. So we have a 12, we have an X, which X, I'm going to say X is this one. Okay? And then we have 15 and 6, and then we have 10 and a Y. All right, I'm going to double check my picture. I'll show you my picture in a second. So 12X, 15, 6, 10, and Y. Okay. Sorry about that, you guys. Jeez, the Demon Cats got me again. They're always getting me. I hate those things. Okay, so here's my picture. I labeled my sides. So we have 12X, 15, 6, 10, and Y. Okay, so I'm going to start by setting up my ratios with the X and the Y. Okay, which I'm going to start from my little triangle first. Because I think when you have these overlapping triangles, sometimes it's easier to start with the smaller triangle. Okay, so X is on this side. X is in between. If I look at my big triangle, X is in between the 1 arc and the 2 arc. Okay, I'm going to put X on the bottom. So I'm going to put the big triangle on the bottom, smaller triangle on the top. Okay, so which side length of my smaller triangle is in between a 1 arc and a 2 arc? That would be side 12. Okay, I'm going to do the same thing with Y. So Y, again, it's in my bigger triangle, so I'm going to put it on the bottom this time. Okay, and this one is in between the 3 arc and the 2 arcs. Which side length is in between the 3 arcs and the 2 arcs in my smaller triangle? You guys are too cool for school. You guys always know the right answer. I'm so proud of you. It would be the 10. Okay, and now I need to find my scale factor, which are the 2 sides that I already have values for. And let me see real quickly. It will reduce down, and like normal, Miss Long didn't plan ahead. Guys, so I'm going to write this up here again. Again, I would probably on your paper write it near the X and Y, but I guess it doesn't matter. Okay, so my scale factor, this is what I'm going to use in both of my proportions. Okay, so the 2 sides I haven't used, well, in my smaller triangle, I've used the 12 and the 10. Okay, I have not used the 15, though. So it's going to be 15 over, and actually, you guys, man, the Demon Cats are getting me bad today. I'm going to have to fix these 2 down here. But it's not like you don't have to erase anything. We just need to add something. But anyway, so in my smaller triangle, it's 15. Now, be careful, you guys. This is a mistake I made down here, particularly with this one. Okay, so the whole length is not just 6. Okay, what is the length of my entire bigger triangle? Because first of all, 15 is in between the 1 arc and 3 arc. Okay, so I need to figure out the side in between the 1 arc and 3 arc, which is this whole side. How do I find this whole side? Okay, well, that side is made up of the 15 and the 6, which means to get the whole side, I need to add these together. So I need to add the 5 plus, or the 15 plus the 6, which is 21. Okay, so my whole side is 21. And this right here is going to reduce down. So what is the number that will divide into 15 and 21? Like normal, you guys are correct. It is 3. So I'm going to divide each of these by 3. So my scale factor, 15 divided by 3 is 5, and 21 divided by 3 is 7. Okay, so the fraction I'm going to use in each of these problems is 5 over 7. All right, now, what Miss Long messed up? Now, the Y is okay because the Y doesn't have multiple parts going on that side. It's just Y. But, let's see here. Okay, so the X, technically the X is just this part, but I'm comparing this side of the triangle to this side, the whole side, not just part X. Guys, so how do I get the whole side? If this piece is 12, if HO is 12 and OR is X, what do I do with both of these to get the entire side length, HR? You do add them together. So down here, I should have done 12 to get this whole side. I should have done 12 plus X. Okay, so we're comparing one side of the triangle to the other side. The small triangle to the big triangle. Okay, so I should have said 12 plus X or X plus 12. Same thing. Okay, so now that we're on the same page, let's start solving. How do we solve a proportion? You do cross multiply. So I'm going to cross multiply. So we have 5 times this whole thing. So I'm going to put that whole thing in a parenthesis. And that will equal the other side, which is 7 times 12. And 7 times 12 is 84. Okay, let's start solving, which I'm going to be distributing first. So whenever you have a number outside of a parenthesis, you distribute that thing. So 5 times x will give me 5x. 5 times 12 will give me 60. And that will equal 84. All right, let's solve this thing for x. So how I bring 60 to the other side, a positive 60, is by subtracting that thing on both sides. So I'm going to subtract it. Okay, which 60 minus 60 will cancel and turn to 0. 84 minus 60 is going to give me a 24. Okay, so I have 5x equals 24. And then the 5 and the x are secretly multiplying. So the way that I move my x to the other side is by dividing both sides by 5. Which 5 divided by 5 will cancel and turn to 1. Now 24 and 5, that will not reduce down any further. So x is going to be 24 over 5. There we go. Okay, let's get going on y. So y is all set. The Demon Cats did not get me on that one. So let's start cross multiplying. So 5 times y is 5y. And then 7 times 10 will give me 70. Okay, let's solve for y. So the 5 and the y are secretly multiplying. So the way that I move 5 to the other side is by dividing both sides by 5, which 5 divided by 5 will cancel and turn to 1. So we have 1y, or just y, equals 70 over 5 is, I think it's 14, but I'll double check. Yes, it's 14. So y is 14. And guess what, you guys? That's it for 15. We only have one more like this, and the next one is actually really similar to 15. So if you felt good about 15, and then you would like to try 16 on your own, I encourage you to do so.